At first, it appeared to be an ordinary asteroid. Small. Dim. Nothing remarkable. But within hours, scientists realized they were looking at something humanity had never seen before. Its speed was too high. Its trajectory was too unusual. And its path through the solar system did not match anything formed around our Sun. This object had come from somewhere else. Far beyond our planetary neighborhood. Far beyond the outer reaches of the solar system. It was the first confirmed interstellar object ever detected passing through our cosmic backyard. Astronomers named it Oumuamua, a Hawaiian word meaning messenger from afar arriving first. The name was fitting. Because Oumuamua wasn't merely another space rock. It was a traveler from another star system. A silent survivor of a journey that may have lasted hundreds of millions, or even billions, of years. As telescopes around the world focused on the object, scientists began collecting data. What they discovered only deepened the mystery. Unlike typical asteroids, Oumuamua's brightness changed dramatically as it rotated. The fluctuations were extreme. This suggested a very unusual shape. Some researchers proposed it was highly elongated, like a cosmic cigar. Others argued it might be flattened into a thin disc-like structure. Either possibility was unlike anything commonly observed among objects in our own solar system. Its surface appeared dark and slightly reddish. A color often associated with prolonged exposure to cosmic radiation. For unimaginable spans of time, energetic particles traveling through interstellar space can chemically alter surfaces, producing complex organic compounds known as tholins. These substances are not signs of life. But they are evidence of rich chemistry occurring throughout the galaxy. Every clue pointed toward the same conclusion. Oumuamua was ancient. It likely formed around another star long before humanity existed. Perhaps it was ejected during the chaotic formation of planets. Maybe giant worlds shifted their orbits and gravitationally launched it into interstellar space. Or perhaps it originated from a violent stellar encounter that destabilized an entire planetary system. No one knows for certain. What we do know is that Oumuamua spent countless ages wandering the darkness between stars. A world without a home. A traveler illuminated only occasionally by distant suns. Then, by pure chance, it crossed paths with Earth. Its discovery revealed something profound. For centuries, humanity viewed the solar system as largely isolated. A collection of planets orbiting a single star. But Oumuamua showed that the galaxy is far more connected than we imagined. Objects travel between stars. Fragments of distant planetary systems constantly drift through interstellar space. Some eventually pass through our own. And if one such visitor could arrive, there must be countless others. That realization changed astronomy forever. Because Oumuamua was not just a strange object. It was evidence that our solar system is part of a much larger cosmic network. A network where worlds, debris, and perhaps even the ingredients of life travel across unimaginable distances. Yet the greatest mystery was still ahead. Because as scientists tracked Oumuamua's journey through the solar system, they discovered behavior that no one expected. Behavior that would ignite one of the most controversial scientific debates of the century. As Oumuamua continued its journey away from the Sun, astronomers carefully analyzed its motion. Initially, everything seemed straightforward. Gravity should determine its path. The Sun pulls. Objects respond. The mathematics is precise. Yet something wasn't quite right. Oumuamua was accelerating. Not dramatically. Not enough to send alarms ringing immediately. But enough that scientists could not ignore it. There appeared to be a small additional force acting on the object. Normally, this would be easy to explain. Comets frequently experience non-gravitational acceleration. As sunlight warms their icy surfaces, gas erupts into space. Those jets act like tiny rocket engines, gently pushing the comet and altering its trajectory. But Oumuamua presented a problem. There was no visible coma. No tail. No detectable cloud of gas or dust. Nothing that normally accompanies outgassing. It behaved unlike every known comet. The puzzle quickly became one of the most discussed mysteries in modern astronomy. Researchers proposed numerous explanations. Perhaps hidden hydrogen ice was evaporating invisibly. Perhaps nitrogen ice was escaping without leaving obvious traces. Others suggested unusual surface chemistry created by billions of years of exposure to cosmic radiation. Each theory attempted to remain within established physics. Yet none completely matched every observation. Then another possibility gained attention. Radiation pressure. Sunlight may seem weightless. But photons carry momentum. When they strike a surface, they exert a tiny force. Over time, that force can change an object's motion. This effect is real. Scientists have even proposed spacecraft powered entirely by sunlight using enormous reflective sails. If Oumuamua possessed an extremely thin structure with a very large surface area compared to its mass, sunlight alone might explain the acceleration. But this introduced a new mystery. For radiation pressure to produce the observed effect, the object would need an extraordinarily unusual geometry. Far thinner than typical asteroids. Far flatter than expected from natural processes. This is where the debate became controversial. In 2018, astrophysicist Avi Loeb suggested a possibility that captured worldwide attention. What if Oumuamua was not entirely natural? What if it was some form of artificial object? Perhaps even a light sail created by an advanced civilization. The proposal generated headlines across the globe. Some people embraced the idea. Others strongly criticized it. Most astronomers argued that extraordinary claims require extraordinary evidence. And no evidence of alien technology was ever found. Even today, the vast majority of scientists favor natural explanations. Yet the discussion revealed something important. Oumuamua was genuinely unusual. The observations were real. The unanswered questions were real. And our inability to fully explain every aspect of its behavior highlighted how little we know about interstellar objects. Perhaps the greatest lesson from Oumuamua is not about aliens. It is about preparation. Humanity discovered it only after it was already leaving. We had no spacecraft ready to intercept it. No instruments capable of examining it closely. By the time we realized how extraordinary it was, the visitor was already disappearing into deep space. That experience changed scientific priorities. Future observatories are being designed to detect interstellar visitors much earlier. Mission concepts such as Project Lyra explore ways to launch rapid-response spacecraft capable of chasing future objects. The next visitor may not escape so easily. And eventually, another interstellar traveler will arrive. Perhaps it will be a comet. Perhaps an asteroid. Perhaps something entirely unexpected. When that day comes, humanity will be ready to learn far more than we learned from Oumuamua. Because Oumuamua revealed a stunning truth. The solar system is not a closed world. It is an open crossroads within the Milky Way. A place where fragments from distant stars occasionally pass through, carrying stories from places we have never seen. And somewhere in the darkness between the stars, countless other messengers are already